In this chapter, we will study about the mathematical expectation. And in this chapter, we discuss about the mathematical expectation. And these are all the topic that we will cover in this chapter. Like the topic that we will be covering in this chapters are expectation of the discrete random variable, theories of the expectation, variance of the random variable, covariance, expectation of the continuous random variable. It simply means that mathematical expectation is mostly used for the random variables. So let us first begin with the first topic. That is the first topic, that is the expectation of the discrete random variables. Suppose that x is the random variable associated with this random values x1, x2, x2, x3, xn up to the xn, and this is the probabilities px1, pxi. This is the probabilities associated with all these random values. For example, px1 denotes the probabilities of the random value x1, px2 denotes the probability of the random value x2, and similarly pxn, that is the probability. This denotes the probability of the random value x1. Now, knowing these two things, we can easily calculate the expectation of the discrete random variable, and this is the formula for the expectation of the discrete random variable, and this denotes the expectation. That is it means it is the notation of the expectation. E denotes the expectation, and this x is this random variable x, and the formula simply states that it is the summation of the random value, all the random values of its random variable multiplied by its probabilities, its respected probabilities. When we expand this formula, we will get this expanded form of the formulas. As we can see, it is simply the summation. It is simply the addition of the multiplication of the random value and its associated probabilities. And now there is also the another definition of the expectation for the discrete random variable, and this definition states that expectation of the discrete random variable is the weighted average of the random variable x. According to this definition, the expectation of the discrete random variable can be written as like this. But yeah, this is very similar to the above, simply that we have divided it by the summation of the probabilities. This is the summation of the probabilities, summation of all these probabilities. And according to the probability theory, the summation of the probabilities is always equal to the 1. For any experiment, the probabilities of its outcomes, random outcomes, are always equal to the 1. Then the formula becomes exactly like the above. Now, this concludes the formulas and the basic ideas about the expectation of the discrete random variables. Now, the next thing I want to talk is about arithmetic mean and the expectation. And the thing is expected mean and the arithmetic means are very similar concept. The only difference is that arithmetic mean is used for the frequency distribution, and the expected mean is used for the probability distribution. What I mean by this is that suppose we have the formula for the arithmetic mean. Formula for the arithmetic mean is calculated like summation x open by number. This x denotes all the values, series values. Or there is another definition of mean equals to summation of x. Summation of x open by num, and this is the frequency based on this is the mean based on the frequency distribution. And for the expected mean we have the formula like Ex equals to, we just have seen this earlier, n. These two, these two are very similar. If you calculate the values, for these two, then these two will give the very similar result. So it simply means that arithmetic mean and the expected means are very similar. Though they are not exactly equal, but they are almost approximately equal with each other. Let us now see how, with the example, how these two concepts that we just discussed, like arithmetic mean and the expected means, are equal to each other. Let us suppose that we are given these values 1, 1, 2, 2, 2, 3, 3 like this, and we calculate the arithmetic mean. This is a very simple way to calculate the arithmetic mean that we have, and the value that we gain by calculating this arithmetic mean is 2.35. I am not going to describe all this, how this was calculated, because this is a very simple concept which probably you have already learned in the middle school, so I will not be discussing this topic. Yes, so simply now the answer obtained from this method is 2.35, 2.375. That is, we get the arithmetic mean value of 2.375 by using, when we used the method of the arithmetic means. Now we'll use the another method like the expected value. We'll use the expected formula that we have shown earlier. Now let S be the random variable associated with the discrete value 1, 2, 3. There is only 3 distinct values, 1, 2, and the 3. Though there are many values, but the distinct values are only 1, 2, and the 3. Then the probability of getting the 1 is, how many times the 1 have occurs? There is only 2. Frequency of 1 is only 2. 2 by all these values 1, 2, 3, 4, 5, 6. There is a number n is equals to 16. Number of values are 16. So this is the way we calculated the probability for each value 1, 2, 3. Like the 2 have occurs, the frequency of 2 is 1, 2, 3, 6. So the probability of occurring to value 2 is 6 by n 16. Similarly, x3 have occurred 8 times. Frequency of the 3 is 8. So the probability is 8 by 16. That is the total number. Then we can use the expectation formula to calculate the expected values. Here we have seen that when we expand this formula, we get x1 p probability of x1 into plus x2 multiplied by probability of x2 x3 by into probability of x3. Now the value of x1 is 1. Probability of x1 is 1, and the value of x1 is 1, and the probability of x1 is 1 by 8, and probability of value of x2 is 2, and the probability of x2 is 3. Similarly, when you calculate this value, we get the value 2.735. As you can see, the value obtained from the arithmetic mean and the expected mean is very similar. Though they are in real time, though they are not always equal, but they are very similar. So this concludes that the arithmetic means and the expected means are very similar concept. Now the next topic I want to cover is theorem of the expectation. According to this theorem, there are basically 2 theorems of the expectation, that is the addition theorem and the multiplication theorem. According to the addition theorem, let us suppose that x, y, z. Let us suppose that x, y, z are the random variables. Then the expectation of the expectation of the sum of random variables is equal to the sum of the expectation of the each random variables. This is the formula theorem of the additional theorem of the expectation. So we can prove this that the derivation can be very long and tough, but for this lectures, for this tutorial, we will not be covering how this theorem is proved, but you can use any standard statistics book to see the derivation. So it simply means that the additional theorem simply means that expectation of the summation of the random variables is equal to the expectation of each random variable, summation of the expectation of each random variable. And this multiplicative theorem is also very same. According to the multiplicative theorem, the expectation of the multiplication of the random variables is equal to the expectation of each multiplication of the expectation of the each random variables. Now there is two remarks. I want to talk about two remarks, like the expectation of E is equal to A, like the expectation of the, let us suppose that E is the constant value, E is constant, A is the constant value, then the expectation of this constant value is equal to the, how do you prove that? Then suppose we can prove it by X equals to, we have the formula of the expectation of 1i n open by x1 open by p exi. You have the formula of the expectation like this, and the E in place of E1 we have E value I equals to 1 open by n, then the variable is A and the pxi. This is constant value, so we can bring this out of the summation. 1 open by n open by pxi, as we talked earlier. So as we already mentioned that according to the probability theory, the sum of the probability is always equal to 1. That is, this value is always equal to 1. That is equals to 1. So the probability answer is 1. And this is the second remark I want to talk is, let us suppose that A and B are the two constant values. Then expectation of A x plus B is what? We can calculate expectation by E x. We can use the additional theorem. We have used the addition theorem like this. The one random value and this is the another random value, and we use the addition theorem to obtain here. And here we can use the multiplication theorem, A and x. They are in the multiplication form. We can use the multiplication theorem here, and E equals to x plus expectation of the constant variable. As we already mentioned that the expectation of the constant value is equal to the constant value itself. So this value is A, and then this Ex, the expectation of x plus B, and this is the result. So there are few other important remarks or the things that we need to consider, but for simplicity we will only end with this 1 or 2 remarks. So the